So the last question, last part of this, the notes today, kind of alludes to something I talked about earlier, how the horizontal flip and the vertical flip are essentially the same. So if we take a look at this original sine function, there's my original sine function. I'm just going to move it over a little bit here. I'm going to slide it over. Okay, and if I horizontally flip this graph, I'm going to do this in red. If I horizontally flip this graph looks like this. It's going to go up, down, down like that. Okay, so that's my horizontal flip of my original sine function. Okay, it looks like that. If I vertically flip it, the vertical flip of this graph is going to look like this. It's going to go like that and like that. Well, notice that the horizontal flip and the vertical flip, although I've kind of drawn them in a different period, that red graph flows directly into the blue graph. In fact, if I were to continue that blue graph on, yeah, it just follows the red. They are the same graph, same with the red. If I were to just follow the red graph backwards here, yeah, it's just exactly the same as the blue graph. So these are in fact equivalent. So this is in fact an identity. We can say that a vertical flip of sine is equivalent to a horizontal flip of sine. And we can change these. So an example would have been an example that we did earlier today, where it was a horizontal flip. There was the first one. Instead of graphing it as a horizontal flip from right to left, I could have graphed it as a vertical flip from left to right. And then we're being, although they're different periods, it doesn't really matter. I don't care which period you graph it in. They're the same graph. Okay, so that's something that we could do as an alternative. Now, we don't have to do one or the other. You have an option there. But I want you to understand they're the same. In fact, because of this, we end up with an identity. We end up with this identity. Say that sine of negative theta is equal to negative of sine theta. They are exactly the same. Okay? And we will see this identity later on. And this is a property of something called an odd function. And odd functions are what we call rotationally symmetrical. Okay? In a sine graph, if you look at a sine graph, if I rotate that 180 degrees, it's actually the same graph. Now, different with cosine. If I take my original cosine graph, I'm just going to draw it over here. Okay? And there's my original cosine graph. And I horizontally flip this cosine graph, it's going to look like this. Okay? I'm going to flip it across the y-axis. Well, is there really a change? Well, no, because if I continue graphing this red graph, well, it just follows the original cosine graph. Okay? If I continue drawing the next period of the cosine graph, yeah, it just follows the negative cosine theta, or cosine of negative theta graph. So a horizontal flip for cosine does not affect the cosine graph. Whether I draw it to the right, like this, as a regular cosine, or to left as a horizontally flipped cosine, no difference. And we can actually use that as an identity. Okay, so if you see the negative horizontal flip for cosine, although if you're not sure, you go graph it right to left, but you don't have to because it does not affect the graph. And this comes another identity that we will see later on. We'll say that cosine of negative theta doesn't change the graph. It's the same as cosine of theta. There is no change. Cosine of negative 60 degrees is the same as cosine of 60 degrees. There's no change when we put a negative on it. And if we want to think of it from the circle perspective, the cosine is the x-coordinate. As I move in this direction, the x-coordinate is the same in the positive direction as if I rotate in the negative direction when I look at it from the circle perspective.